All right, good morning, guys. Just a overview for today. All right, so today's Wednesday. So you have an attendance quiz on Teams. Excuse me. We're gonna do topic 7, SAS 1, SAS 2. Pay close attention because there are a couple of pages or a couple of numbers that I am going to skip. Also, a lot of you have not done your lesson from yesterday. So you need to go back and make sure you complete that by 3 p.m. today, because I take that for a daily grade and you rack up on those zeros. It really hurts your grade. So be sure to go back and go through the lesson. There's a video on it. You can always email me if you have questions, whatever. But I think that's it. Let me think. Yeah, that should be it for today. So I'm going to go ahead and get started. We're on page 182 in our workbook. And so page 182, and I just paused the video and went and fixed the Agile Mind lesson, so it brings you to the right page that you need to be on. So when you click on topic 7, SAS 1 and SAS 2, it should bring you to this page. So first, before we go through this module, I want to go to the workbook page with you. And exponents and radicals have rules, okay? You will have a quiz on Friday over these rules. So what you'll have to do is you will have to choose which rule goes with each thing. So on this first one, what do you notice the sign is in all of the examples on the left? What's a multiplication sign, right? So over on our rule side, we're going to write multiplication rule. Now, on the multiplication rule, your bases must be the same. Okay? So, an example, x to the a power and x to the b power. Now, here's the rule. When your bases are the same and you're multiplying, you simply add your exponents, okay? But your bases have to be the same. So you could not have a 2 and you cannot have a 3. You would have to have a 2 and a 2 or a 3 and a 3. So I would also like you to write in that box, bases must be the same. Okay? Now, I'm going to go over to Agile Mind and we're going to work through these. Okay? So this is what's on your example on number 3. So make sure you click through it on here on Agile Mind and you copy it to your workbook. So we have a first example. We have 2 to the 3rd power and 2 to the 5th power. Well, I don't know what that means. So look, our bases are the same. So if our bases are the same, we can add our exponents. So we just say 3 plus 5, does that equal 8? Yes. So this one would be equal. Okay. What about the one to the right? 2 to the 3rd power times 2 to the 5th power. Our bases are the same. They're both 2. And we add our exponents when we are multiplying. Well, is 3 plus 5 15? No. So this would be it does not equal. All right. On the third one, a to the negative 2 power times a to the 10 power equals a 12. So we take, our bases are the same, a and a, negative 2 plus 10. Is negative 2 plus 10 12? Nope, it's 8. So this is a not equal. Now, what about the one to the right of it? A negative 2 times a to the 10th. That one would be correct because negative 2 plus 10 is 8. Now, on these bottom ones, this is where it might get tricky. So, we have an x and a y. Are those bases the same? No. So, I cannot add those exponents. Okay? But what I can do is exactly what they've done here. I just rewrite it. X to the 4th, y to the 2nd. So, this would be correct. However, the one on the right, x and y, not the same. So we cannot add our exponents. But what did they do? They added their exponents. So can you do that? No. So that one is not equal. Okay? And then if you hit rule, it shows you the rule again. It says if two exponential expressions with the same base are multiplied, the result is an exponential expression with the same base whose exponent is the sum of the exponents. Okay, so remember, when you're multiplying, your base must be the same in order to add your exponents. All right, if you click the number 2 at the bottom, it brings you to the next box. And this is going to be the division rule. So, bases must be the same. So go ahead and write. Bases must be the same. Okay, so we have an x to the a and an x to the b. Well, guess what you do now? XA minus b. So here, when you are dividing, you can subtract your exponents if the base is the same. Okay, so remember, division, subtract exponents if the base is the same. Okay? So now on your examples, on this first one, our bases are the same, 2 to the 5th, 2 to the 3rd, but it says our answer is equivalent to 2 5/3. Is that correct? Nope. All right. On the right, 2 to the 3rd divided by 2 to the 5th. So I can say, since my bases are the same, 3 minus 5 equals -2. So that is correct. Now, down here we have an A and an A, so they're the same, so we can simplify, we can subtract them. So we have a -2 minus 10 is a -12. So that one is correct. All right, what about the one to the right of it? 2 to the 5th and 2 to the 3rd equals or not equal 2 to the 2nd. Well, that equals because 5 minus 3 is 2. Now, this is where you got to be careful on the bottom left one. So we have a 10 and a -2. So do I just say 10 minus 2? No. I say 10 minus a negative 2. Still have to subtract those two exponents. No matter if they're positive or negative, I still have to subtract them. So here, 10 minus negative 2, these two negatives become a positive. So I have 10 plus 2 now, which equals 12. So that bottom one is correct. Now the one to the right, we have a negative 2 minus 10. Does that equal positive 8? No, it doesn't. It equals negative 12. So this is a not equal. Okay? So if you hit rule, it shows you the rule. We've already written. Just know if your expression is being divided, you can subtract your exponents if the base is the same. All right, this next one, if you click the 3 at the bottom, it brings you to the next section, and this is the easiest one. So it is called the power rule. And all you do is you multiply your exponents. That's all you do. Multiply your exponents. Okay. So now, let's go back. On the first one, 2 to the 3rd power raised to the 5th power. 3 times 5 is 15, so that is correct. To the right of it, 2 to the 3rd raised to the 5th is not 2 to the 8th because the power rule tells us we must multiply. So this is not correct. The one right here is negative 2 and 10, 8. Nope. However, the one to the right of it, a negative 2 and a 10 is a negative 20, so that is equal. And the one in the bottom left corner, a negative 4 and a negative 2 does make a positive 8. However, the one to the right of it does not make a negative 8. So if you hit the rule, it says the exact same thing I've said. If an expression is raised to the power, the result is an exponential expression with the same base whose exponent is the product of two exponents. Okay? The word product means to multiply. Okay, the next one, if you hit the blue 4, it'll bring this up. Now, this one is a little bit tricky, and we often forget about this rule when we are simplifying these expressions. So, this one is the negative exponent rule. So, and it has 3 different, I guess what you would call subrules. So, the first one, let's say I have a base with a negative exponent. Okay, well, we don't really want negative exponents because we don't really like negatives. So, we simply say 1 over x with the positive exponent, okay? So if I were to make this original a fraction, it would look like this. So all I'm doing is I'm flipping it and making that exponent positive. Now, if it's the other way, 1 over x negative 8. Well, there's a negative exponent on the bottom, but I don't like that. So guess what I do? I put it on the top with the positive. Okay? The last one, let's say I have an x over y with a negative exponent. Well, I don't like negative exponents. So you flip your fraction and you make a positive. Okay? So I'm going to go through this again because this one's a little bit different. So the first one, let's say I have a base with a negative exponent. Well, remember, we don't like negatives. So we're saying 1 over x positive exponent. Now, let's say I have my fraction first. So I have 1 over x with a negative a exponent. But remember, we don't like negatives. So I swap that to x with a positive a exponent. The last one, all right, the last one is if I have, let's say a fraction, my fraction is going to be x over y, and I have a negative exponent. Here's what you do. You flip your fraction with a positive exponent on my numerator and my denominator. Okay? So now, if we go to add your mind, on this first one, I have a 3, negative 2. Remember, I don't like negatives. So it should equal 1 over 3 squared. But is that what this says? Nope. So that is not equal. But the one to the right of it says 3 to the negative 2 equals 1 over 3 squared. Is that correct? That is correct because it changes the sign. Now, below, we have 1 over 3 with a negative 2 exponent. Now, to change that, we would need a 3 squared. But that says negative 3 squared. Is that correct? Nope. So this one is not equal, but to the right of it, it is correct. Now, below in the bottom left corner, we have our fraction, 2 over 3 to the negative 4. So remember, we flip our fraction, and we put the positive exponent on both. So does this match this? Yes. So this one is equals, but the one to the right, it is so wrong. They didn't even flip their fraction. So if you hit rule, it shows you all the rules that we just talked about, okay? So it says the exponent expression with a negative, the exponential expression with a negative exponent can be rewritten with a positive exponent as the reciprocal, okay? So that reciprocal means to just flip it. So if it's on the bottom, you put it on top. If it's on the top, you put it on the bottom, okay? So you're just flipping it, and you're putting the positive exponent with it. All right, so the last one is so easy, and you know this. So all we're going to write is anything to the 0 power equals 1. That's all we're going to write. Anything to the 0 power equals 1. I don't care what it is. If I raise you to the 0 power, you're going to be 1. Remember, we talked about this a couple of topics ago. So, on Agile Mind, we can do this one very quickly. 2 to the 0 power equals 1. Yep, because it says it equals 1. The one to the right, it says 2 to the 0 equals 0. Nope, that's wrong because it has to equal 1. This is 1. This is 1. This is not correct. And this is not correct. If you look, all of these examples are raised to the 0 power. So, in order for them to be correct, they must all equal the number 1. Okay? Now, if you click to the green arrow to page 6, it gives you a summary of what we just talked about. So the multiplication rule, base is the same, you add them. Division rule, base is the same, you subtract them. It says, note, the multiplication and division rules only apply to the exponential expressions with the same base. Okay? You only have to have the same base for multiplication and division. Now, the last 3, we have the power rule. Remember, for power rule, we just multiply our exponents. For the negative exponent rule, remember, you just flip it and use the positive exponent. And the last one, anything to the 0 power equals, equals 1. Okay? All right. Now, on number 4, this is a reinforced, so it's not on Agile Mind, but it is in your workbook. These are just practice problems. So we're going to work through these together. And then I'm actually going to stop this video and go ahead and upload it. That way you can go ahead and get started. Okay? So, on 4A, it says 5 to the 3rd times 5 to the 4th. Well, that's the multiplication rule. So our bases must be the same. Since our bases are the same, all we have to do is add those exponents. So we keep our base and we add our exponents. 3 plus 4 is 7. Easy enough, right? Now, on B, it is also a multiplication rule, but you see 2 different bases. But how many 3 bases do you see? I see 2. One here and one here. So guess what you can do? You can combine those 2. So I have a 6 plus a negative 2, which would leave me with a 4 times, and we're just gonna leave that 4/3, or not 4/3, but 4 cube. Because we can't combine it because the bases are the same, so we just leave it. On the next one, our bases are the same, but we're dividing this time. So what do I do with my exponents? Well, I subtract. So I keep my base and I say 5 minus 2. Or do I say 5 minus negative 2? 5 minus negative 2 to get x to the 7th. Okay? Okay. So the bottom 3, they went from super easy to like extra complex. So be sure you pay close attention. Okay? On this first example, there's nothing I can do with, actually, let me go up here and let me rewrite this so we have more room. Whoops. All right, so we have 3x to the 5th over y to the 4th times 3 cubed x negative cube over y squared, and all that's raised to the negative 2 power. All right, so we've got all kinds of things going on. We've got multiplication rule, we have a negative rule, we have a power rule, we may have a division rule, we've got it all. Okay, so first thing you want to do, this first section, there's nothing I can do with it right now. So I'm simply just going to bring it down and get ready to simplify with it in a little bit. Okay, I say a little bit like it's going to take all day. In just a minute. Okay, so now, the second part, we have that power rule because we have that negative 2 outside the parentheses. So, we're going to keep all of our bases. So we have a 3 base, we have an x base, and we have a y base. Okay, so first what I'm doing is I'm saying 3 times negative 2. Well, that's a negative 6. Okay. Now, I'm saying negative 3 times a negative 2. And I'm getting a positive 6. Now, I say 2 times a negative 2. And I get a negative 4. Okay. So, we've done our power rule. So, now we want to simplify. So, we have multiplication and we have division. So, let's look at the y's first. Our y bases are the same. They are multiplying, so we can add those exponents. But 4 plus a negative 4 just does what? It just goes away. So that is a y to the 0, right? All right, let's combine the top. What exponent is on this 3 right here that we just don't see? We don't have to write it. It's a 1. Okay, so now I can combine my 3 bases. So I'm saying 1 plus negative 6, which leaves me with a negative 5. Everybody agree? Okay. Now we have x. We can combine our x's, so 5 and 6 is 11. Am I done? No. I can still simplify 2 things. Anything to the 0 power is what? 1. Can I have a negative exponent up top? No. So where do I have to put it? If it's on the top, I simply just move it to the bottom. So I'm going to rewrite that up here where you can see it. So we have x to the 11 on top. And on the bottom, we have 1 times 3 to the 5th, which is just 3 to the 5th. So that is my answer for the first one. Now, for the next one, for E, 12x cubed y negative 6 divided by z to the 4th times x squared y cubed over 4z negative 10. So the first thing, if you ever have coefficients out front, remember coefficient is a number, you always want to go ahead and write those. So I have a 12 on top and I have a 4 on the bottom. Okay? Now, let's combine everything on the top. So I have a y cubed right here not y, I'm sorry, x cubed and an x squared, which when you're multiplying, remember you add them. So we have x to the 5th, okay? Now we combine our y's. Y negative 6 and y cubed. So a negative 6 plus 3 is a negative 3. Now we combine our z's. Z4 and z negative 10. We're multiplying. So 4 plus negative 10 leaves me with a z negative 6. Now, I want to simplify. So first, what I want to say is 12 divided by 4 is 3. Now, can we leave our x to the 5th alone? Yes, because it's positive. There's nothing we want to do. So we have x to the 5th. Now, if you look, that y has a negative 3, and that z has a negative 6. So we have a negative exponent on the top, and we have a negative exponent on the bottom. So what should we do with those two places? We should just swap them, that way they become a positive exponent. So here is my answer. Okay. Now for the last one, the power rule, super duper easy. So we have a 5x negative 2 and a y to the 5th, all to the 3rd power. So I'm literally multiplying everything to the 3rd power. So we have 5 to the 3rd power. We have x to the negative 6, and we have y to the 15. 5 cubed, but where does that x need to go? It's on the top now, but it needs to go to the bottom, and our y can just stay because it's positive. All right, so that is all for the overview, SAS 1. So I am going, because we skip number 5 on the back. So I am going to go ahead and upload this video. That way you can go ahead and get a head start. Then I'm fixing to start on SAS 2.